Hey guys, right now we're going to talk about angles and their measures. There are two kinds of angle measures. We have been working so far with radians, and we denote radians as the measure of angle alpha in terms of radians, and that is where our unit circle let's try this again. Unit circle is divided into 2 pi unit arcs. Now we're going to add in degrees, and you all are probably familiar with degrees from geometry, and we're going to denote that by the measure of angle alpha in our lovely degree symbol, and here the unit circle is divided into 360 congruent parts. So if you go back to the lovely unit circle, and that is horrible, but you're going to bear with me, that we did the first week of school, and we divided this into radian measures. We had 0 to pi, we had pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi. Keeping that going, we had 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, and 11 pi over 6. So now what we're going to do is we're going to match these up with degrees. So here we have 0, 360 degrees, 30 degrees, 45 degrees, 60, go away, 90, and continuing over here, this gave us 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, and 330 degrees. So that's matching all of our unit circle radian measures to the unit circle degree measures. So now let's talk about converting between degrees and radians. Formula that you need to know. The measure of angle alpha in degrees equals take your measure of angle alpha in radians and multiply that by 180 degrees over pi. It's like unit cancellation. This is going from radians to degrees. And if we want radians, then take your degrees and multiply that by pi over 180. And this is going from degrees to radians. So those of you in chemistry should be familiar with unit cancellation. Think of it in the idea that if we have radians, that involves pi. We need to get rid of pi, so we divide by pi, multiply in by degrees. Vice versa for going the other way. So now let's do some examples. One. Write 3 pi over 5 radians in degrees. So when we do that, we're going to take 3 pi over 5, and we want it to go to degrees, so we're going to multiply by 180, divide by pi. When we do that, we are going to, the pi's will cross out, you get 3 times 180 divided by 5, and you should get 108 degrees. Going again, let's say that alpha equals 0.81 radians. And we'll say again, find alpha in degrees. The only difference here is our radian measures a decimal, but we're still going to do the exact same thing as multiplying by 180 over pi. And when you type that into your calculator, you're going to get 46.4 degrees. And you can just go to one decimal place. That's absolutely fine. 3. Write 200 degrees in radians. Well, we're going to take our 200 degrees and we are going to multiply by pi over 180. Remember, unit cancellation, our degrees are going to cancel out. And when we do this, we are going to get that this equals, we could say 10 pi over 9 radians. Or if you used your calculator, maybe it just gave you the answer of 3.49 radians. And number 4, this will be our last one to wrap up the video for today. 499 degrees. Find the measure of angle alpha in radians. What do? Same thing we've done before. Take our degrees, multiply it, bring in pi, take away the 180. And when you set this up, this doesn't reduce nicely to give us a nice friendly answer like 10 pi over 9 did in number 3. So we are just going to get 8.71 radians. Now you're probably wondering, do you have to include the R every single time in the degree symbol? The answer is yes. You have to clearly denote between the radians and the degrees. Okay? Hope you found this nice and easy. We'll continue with this next class after your inverse quiz. Have a good one.